All right, so we've been spending a lot of time working on our trig identities. We're going to switch gears here a little bit, and we're going to start solving some trig equations. And I think we should be well prepared for this. There might be a couple techniques that we'll be like, oh, well, I guess that makes sense. Some techniques that we're familiar with using in solving other types of equations. We'll see how they play out in solving trig equations. However, our identities will be helpful. Also understanding how our inverse trig functions, arc sine, arc cosine, and so on, how those will be helpful. So let's take a look at this first one. Okay, and we want to find where does 2 times the sine of x times the cosine of x equal the square root of 3 times the sine of x. So we'll talk about how we're going to solve this, and we'll remind ourselves how we can check an answer. What does it mean that we're actually solving the equation? So one of our main techniques that we use when we solve equations is we like equations that are equal to 0, because if they're equal to 0 and we can write it as a product, we can use our 0 product property. So let's do that. Let's get this thing equal to 0 by, let's see here, subtracting the square root of 3 sine of x on both sides. Okay, now on the left side, those aren't like terms, right? So we're just going to have to write that as 2 times the sine of x cosine of x minus the square root of 3 sine of x equals 0. Okay, so that's good. We got it equal to 0. Now, what do we like to have equal to 0? We like it when it's a product equal to 0. So how can we make this a product? Well, factoring is how we rewrite things as products. And when I look at this, I notice that there is a sine of x in both terms. So let's factor that out. Let's see, that's going to leave me 2 cosine of x minus the square root of 3 equal to 0. So now we can use our 0 product property, and we can say the sine of x equals 0, or 2 cosine of x minus the square root of 3 equals 0. And now we can solve those individually. Let's start with the first one. Okay, where does the sine of x equal 0? Well, hold on, I should scroll back up here. The directions I gave here is solve for x's that are greater than or equal to 0 or less than 2 pi. So we're going to do that first revolution only. We'll look at some examples down the road on how we give all of our solutions. So we want to know where in that first revolution is the sine of x equal to 0. And I've got our unit circle here. Where is the sine equal to 0? Sine is the y coordinates at 0 and pi. So we get two solutions there. We get x equals 0 or x equals pi. Over here, well, when we had the sine of x equal to 0, that was really nice. We could just look at our unit circle. So let's isolate the cosine of x. Let's add the square root of 3 on both sides. Let's divide by 2. We get the cosine of x equals root 3 over 2. So then again, where in that first revolution is the cosine equal to the square root of 3 over 2? That would be at pi over 6. And 11 pi over 6. Okay, so in the first revolution, how many solutions to this equation do we have? We have 4. And if you're like me, you'd like to probably put these in order from least to greatest. So we'd have 0, pi over 6, pi, and 11 pi over 6 as your 4 solutions. Now, how can we check our answers? Well, let's go back to the original problem. Well, we can check our answers by graphing. Let's graph 2 times the sine of x cosine of x. And let's graph the square root of 3 times the sine of x. And let's find out where they intersect. Oh, let's see here. Let's go y equals. And I know whenever I'm in Desmos, it wants me to put parentheses to be really clear about what's in the angle. There we go. There's 2 times sine of x cosine of x. And then if we graph the square root of 3 times the sine of x, we get that graph. Now we're looking for where in that first revolution from 0 to 2 pi are these equal. Well, notice they intersect at the origin at x equals 0. They intersect right there at pi over 6. They intersect at pi, and they intersect at, oh, there it is, 11 pi over 6, and that's good. And then it would be back at 2 pi, but we're not including 2 pi because that's the same, it's a coterminal angle with x equals 0. So there we go. We feel good about how we solve this equation. All right. Let's look at the next one. Sine of x plus the cosine of x equals 1. Where does that happen? Well, we said we like them equal to 0, and that still holds true. However, if I subtract 1 over here, I would have sine of x plus the cosine of x minus 1 equals 0. And is that something that I can factor? No, there's nothing I can factor out. It's nothing that I can factor. So to get it to something that we can factor, let's actually square it. Let's make it a product so that we can write it in a way that we can factor. So I'm going to square both sides. Now when I square both sides, I have to FOIL this out. Sine of x plus cosine of x times sine of x plus cosine of x equals 1. And we're going to get a sine squared plus, now what happens when I take the outside times the inside? Outside sine of x times cosine of x, or sine cosine. When I do the inside, I have cosine times sine, cosine sine, which is the same as sine cosine. So we actually end up with 2 sine of x cosine of x, and then we have a plus cosine squared equals 1. Now, I like this mostly because I notice I have a sine squared plus a cosine squared. And what is sine squared plus cosine squared? Well, that's equal to 1. That's our Pythagorean identity. So we see that coming into play here. This is 1 plus 2 sine of x cosine of x. So these two underlying pieces put together are 1 equals 1. Now we can see it's really easy to get this thing equal to 0 by subtracting 1 on both sides, and now we have a product equal to 0. Now if we divide by 2 on both sides, we just get sine of x times cosine of x equals 0, so we have the sine of x equals 0 or the cosine of x equals 0 using our 0 product property. Now, where do these things happen? I can flip to the unit circle. I don't think I need to. The sine is equal to 0 at 0 or pi. The cosine of x is equal to 0 at pi over 2 or 3 pi over 2. So it looks like it happens every pi over 2. It happens at 0, pi over 2, pi, 3 pi over 2, it would happen again at 2 pi. Okay, let's check our answer. What was our original equation again? There we go, sine plus cosine, where does that equal? 1. Oops. Sine plus cosine, and where does that equal? 1. All right. 0. Good. Next one. Pi over 2. Good. Next one. 2 pi? Where did pi over 2 and 3 pi over 2 go? Why aren't they there? They're clearly not solutions, right? That's down here at where? If we put in x equals pi, notice it intersects when the curve is equal to -1. And if we put in 3 pi over 2, that also intersects where our graph is equal to -1. And the reason that happened is when you square things, when we square things, it always makes it positive. So sine of x plus cosine of x actually equals -1 at pi and 3 pi over 2, but because we squared it, it thinks, I shouldn't say, it thinks it's an equation, it really doesn't think, but it acts, I should say, like it's really equal to +1 when it's equal to -1. So it's important that we check for extraneous solutions. Whenever you square something, and maybe you've noticed that in the past, we can run into issues with our solutions. There we go. Okay, we had to get rid of this one and that one. 0 and pi over 2 are two solutions. All right, let's go to another problem. Sine squared of x minus 1 equals 0. A lot of these type of equations, I hope that you can recognize that they're kind of, they're similar to simpler versions of the equations. For example, this kind of reminds me of x squared minus 1 equals 0. Okay, and I hope it reminds you of that. Instead of an x, we just have a sine of x. We're just squaring something different. So how can I solve this? Well, I can add 1, take the square root to solve, or this is a difference of perfect squares, and I can solve it by factoring. It's totally up to you. What I'll do on this one is I'll just do the add 1 route, and we have sine squared equals 1. Let's take the square root, and we get the sine of x equals plus or minus 1. So really, the sine of x equals 1, or the sine of x is equal to -1. Where does the sine of x equal 1? Let's go back to our unit circle. That happens only at pi over 2. Okay. Where does the sine of x equal -1? That only happens at 3 pi over 2. I guess that's off the screen there a little bit. There we go. There's our -1. 3 pi over 2. Do we have any extraneous solutions on this one? Let's check our answer. Sine squared. What I'll do is I will just put a parenthesis like that to make sure I am squaring the sine and not just the x. And it was -1. I don't need another line here because we're just trying to find where this is equal to 0. And there it is at pi over 2 and 3 pi over 2. Those are our only solutions in our first revolution. All right, let me just take a peek at what our next problem is. Yeah, we're going to wait for our next video to look at the next problem. So there's a good start for solving trig equations. I'll see you again in a minute.